Okay, guys. So yeah, let's get started. I'm hoping I will be able to finish this editorial before the contest. Let's start with the first problem first. Okay, so first problem, it's pretty simple. Basically, we just take input and we have to print minimum first and then maximum. You can find minimum or maximum by comparing, and in a language like C++, you would have inbuilt function. You can just use min of xy and then max of xy, and then just print it. You will be done. Let's go to problem 2. Okay, so for problem 2, the main idea is that basically we want to change string in some way, and that like we want to rearrange the characters of string, and we want to have a different string. So like first, like pause for a second here in the video and try to think in which scenario it will be impossible. Pause here and try to think. Okay, there is just one scenario, which is when all of the characters are same, just like the second example here. So in that scenario, there is just one arrangement possible. So of course, we can't make the string different just by like rearranging the characters. So yeah, we can check for that scenario. If that is there, then we say no. Otherwise, we always know answer is yes. We just find any two different characters, and then we just swap them and then print the string. For finding two different characters also, that is pretty simple. You can just iterate through the string, and whenever you get two adjacent different characters, just swap them and print the current string. You will always have that kind of a scenario, because if all characters are not same, then at some point two adjacent characters will be different. Okay, problem B is done. Now we comes to problem C. This could be like little harder than the first two. So the idea is you have a circle here, and then four different points are taken, and then these two lines are made. One main thing to notice here is that all of these points are distinct. So like we don't have to worry about what if lines are colliding or something like that. So either because they are distinct, either they are intersecting or they are not. So the main idea here is that, and the only idea which you need is, okay, take let's say A or B. This is A, this is B. We take A and B, and then we iterate through A to the B in this arc. Basically, we start from here and we iterate through here. We start from 10 and then we iterate up to 6, or you can start from 6 and iterate up to 10, and you count how many points like out of C and D are between those. If no point is there, then we know there is no, let's say here we have a circle. This first line is this. If both of the, let's say this is A, this is B, if both of C and D, we go from A to B. If both of C and D lies in the other half, basically from A to B we found 0, then we know the whole line is in the other half and we are not intersecting. If both of these C and D are here, then also we know there is no intersect. So we just go from A to B and we count how many numbers out of C and D are there. If the count is 1, then we know one point is here and second point is here. Then there is no way for that line to not intersect. So in that scenario, line will be intersecting. So that's simple. And iterating from A to B, we can just iterate directly, because A to B is just 12. So iterating would be fine within the acceptable time limit. Let's go to problem D. All right. So in problem D, basically we have to make these cuts. Okay. So let's try to make sense of it. Okay. So let's say we have this string 0 0 and 1 1 1 0 0 1 0 1. So like I'm going to make a claim first. First claim is that whenever we get a scenario like this, whenever we have a scenario like this 1 0, then we don't have a choice. We have to make a cut between them. Try to like pause the video here and try to think why is that. The reason behind that is that because this part is not sorted. This part is not sorted because 0 should come first and then 1. So in this scenario we don't have any choice. We have to cut it here from here. Okay, that is done. So first part is this: we cut from everywhere where 1 0. We just look at the adjacent characters. Okay, when we have 2 0 as adjacent character, then we are fine. There is no need of cut here. Why? Because both of them are same. So in the end we don't need a cut. Same goes for two consecutive ones, two consecutive ones. Then there is one scenario remaining, which is first we have a 0 and then we have a 1. If we look from a final sorted string angle, it feels like okay, 0 and 1 is fine. 0 is coming first and then 1 is coming, so like probably we are fine, right? That's our like first feeling. But the thing is, let's say we have a string like this 0 1 0 1. So by that logic it feels fine, first part and the second part, but it is not. Why? Because our final string, after we sort, it should be like this 0 0 0, first all zeros and then all 1. So that tells us that this pair can only come once, 0 1. Yeah, so that's it. We are done. We just count number of 1 0 pairs and plus count number of 0 1 pairs minus 1. Minus 1 is for this scenario because we can have 1 0 1 pair, so there is no need of cut in that one scenario. That's it. And yeah, of course, this minus 1 will only come when we at least have one such scenario. Okay, let's go to the problem E. All right. So this problem have basically we are given this A array, which is the location of all the points, and then B array, which takes the time. So if you want to find D, right, our first thing is that we want to find the nearest station which it will cross. What I mean by that is, let's say we have this line 0 point, first point, second point, 3 point, fourth point, 5 point. We have like distance for all of these points, let's say 0, 10, 15, 20, 22, 35. And so we have whenever, and we have time corresponding to that. Time will also be there and that in the top. Okay, so the idea is whenever we get a point which is, let's say, d is equal to 21, so the first goal would be we want to find out where d lies. In this scenario, d lies here. So let me tell you the obvious solution for this, which should come to your mind, as a first sort of idea or like thinking. And if it doesn't, then it will after some practice. But yeah, there is an optimized solution also. But yeah, first solution is that we have this array and this array is sorted, right? So we can just do a binary search here. And for C++ language, you directly have lower bound function, which you can directly use on a sorted array. You have this function, which inbuilt function, which you can directly use. But yeah, the idea is we do a binary search and we find out, okay, 20 is that minimum point where which we have to cross. So that part is clear, right? Because this array sorted, we can do that. After that, what happens is we do this. Let me just write this. Okay. Yeah, the key idea in the problem is that they are saying between any 2 points, speed is same. So what we can do is we can do 22. Okay, let's write time also. Let's say time here is, for this it is 0, 7, 12, 15, 25, 45. So between these 2 points, we will use our basic maths. It will be how much time we are taking. Time taken is 25 minus 15. How much distance we are covering? 22 minus 20. So we have our speed and then we multiply by how much we have to cover. 21 minus 20, because we are at 20, right? We just need to go 1 point ahead, and then so this is our speed, this is our speed, and then we multiply speed by distance to know the time. One thing you should take care of that is first multiply these two things and then divide, so that to take care of the integer errors. If you first divide, then the integer will come something else, and then multiply may not give the perfect answer, because in the end we have to round it down to the nearest time. So first multiply these two and then divide. Of course, take care of things like take like long here. So first divide, first multiply, and then divide, and then you will have your answer. Okay, so this is the obvious solution. This is what I did and it would work. But one more optimized version is that in this problem, we already know all the distances, and we like everything is given already. So we don't have to like answer queries one by one. There is one better way, which is we can like sort the queries with their D, by their D, and then we can use a 2-pointer approach. One pointer is here, one pointer is on the queries D, and we can answer all these queries in like linear time. Basically, we can save our binary search by doing that. But yeah, for the time constants, that is not needed, but that is an optimal solution I wanted to like share with you guys. Okay, I hope it was clear, but if something is not clear, then let me know in comments. I will try to like reply to comment. Okay, let's go to problem F. All right, this is a problem. We want to find this. Basically, all the possible integer coordinates which lie between these two, like distance is greater than r, but strictly less than r plus 1. So for problems like this, right, there is a one general technique which is super useful, which is, so they are telling you to find, okay, f, just wait a second. Question is asking us find where distance is greater than r but less than r plus 1. So in many of these problems, this idea can be used. Okay, if what if I can find a function which give me the answer for x. So it finds count of points less than x. If I have this function here, Then I can just do this function r plus 1 minus function r, correct? Because if I want to find out all points when distance is greater than equal to r but less than r plus 1, right? So if I have a, let's assume I have a magical function which gives us function x will give us number of points which are distance less than x, then I could simply do this. I calculate all functions before with I calculate function r plus 1 which would give me all points less than r, and then I subtract this. Like, just try to understand this technique. This technique is very helpful in many problems like this, and especially like when we have something, okay, find from L to R, then we just find f of R and then we subtract f of L minus 1 from it. So this is a general technique which could be useful in many scenarios. All right, so now we just want to find this function x, right, for here problem. If we found the function x, then we would be done. Okay, so let's try to find function x. First of all, r is less than equals to 10 to the power 5. So let's say I assume I have point I comma j and I iterate I from 1 to 10 to the power 5. Then for from 0 actually. I'm doing this in a loop. Then can I find out how many total possible j's are there? Yes, I can do it. Maximum distance is, so let's say for that iteration of our fx, the distance we are trying to find is x. I'm intentionally using x so that you don't confuse it with the original r of the problem. So x is the input in this, like for this times function's call. So what we can do is, for particular I, we can just find this. We can just do this x multiplied by x, which is x square minus I square, correct? And this I will also go only till x, because yeah, if it's greater than x, then distance is greater only. So yeah, we just do this counting, and there is one case, whatever this count comes, all those values of j are possible. Where did we get this formula from? Can you like pause the video here and try to think, where did we come from this? Just a big hint, we came, like we know this from the distance formula, right? So if we find distance of I comma j, it will be I square plus j square is equal to the distance, right? So if the maximum distance possible is x square, then we subtract it from I, then we have, so sort of, let's say if it comes 5, so all of the values less than equal to 5 would have, like would have distance less than x. Are we done? There is one issue though still. Like I would really encourage, try to think of that, like pause here and try to think of that issue. Okay, issue is that we are asked, we want to find distance strictly less than x. It shouldn't be equal to x. So we can just check a condition which would be if I square plus count square, count is just our possible j, right? So we can just check if it is equal to x square, then we subtract, reduce count by minus minus, and we are done. This is like one edge case which we need to care for. Okay, so by doing this we can calculate, and one thing is that whatever, so let's say we have this answer variable and we are adding count to the answer, then in the end what we can do is we can multiply answer by 4. Why? Because this is distance, right? So the positive, negative, like I or minus I, both are same. So we will have 4 possibilities like that. Correct? Okay, problem F is done. Let's go to the problem G. Okay, so for problem G, one main idea that we have to think is that what does this condition means? Actually, this problem is like relatively simpler once you get this main idea. What does this condition means? Okay, so first look at any possible bit. Okay, if we have one bit, let's say we have a number and the binary formation is this, and then we have a number, binary formation is this. So what will be the XOR of these two numbers? It would be 1 0 0 0 1. So the main idea that we can see from here is that XOR is equal to 1 if bits are different, and it is equal to 0 if bits are same. So if the bits, like if the XOR of, like, try to think about this and internalize this. This is the main idea for this problem which we need. So if XOR of x comma y is, let's say z, and which is less than 4, then from this we know if it is less than 4, then only first and the second bit, those two bits, like the least significant bits, only those two bits can be different. Everything else have to be same. Why? Because if any other bit is not same, then XOR will become more than 4. Because if any bits are not same, that bit is 1 in the XOR, right? Yeah, so that's it. To be honest, problem is done. That was the only critical idea. So now we have to know which numbers we can swap. So for any number ai and aj, if we remove first two bits, like remove two least significant bits, after removing two bits, whatever part is remaining, right, the remaining 30 bits, if those, if that part is same, remaining bits, by removing two least significant bits, what we can do is that we can just set them to 0 or anything. Correct? So if the main idea is this only, if after removing two least significant bits, if the remaining bits are same, which means that if the remaining numbers are same, then we can swap them, because only their first two bits are different, which would mean maximum, like first bit contributes to 1, second bit contributes to 2, so which mean maximum XOR difference can only come as 3. So after removing two bits, if the remaining numbers are same, then we can swap them. If the remaining numbers are same, then swap is possible. That's it. So remove two bits, and then we will have these groupings, right? Which numbers, like which numbers can be swapped with one another. All of those numbers which are remaining, these numbers are same, then we can swap them. So we will have these like sort of groupings, 4 groupings at max. Like no, not 4 actually, we'll have many groupings, but the idea is that whatever groupings are there in one group, we can swap all of the possible numbers. Just to give an more idea, okay, let's say we have these numbers 1 0 1 0 0 1. This is the LSB, this is the MSB, and then we have 1 0 1 0 0 0 1 0 0 1 1. So for the number, first number, this number have this part same and this part same. So first and 3 can be swapped. but this is not same with these two. So first and 3 can be swapped, but the second cannot be swapped. So for this, first and 2 would lie in the same group, second would lie in the same group, or let's say if there is one more number which is like this, so second and fourth will lie in the same group. So that's it. We just make this group by using the above logic, and then we swap, we just sort the each group independently, and whatever the final array is there, that's the answer. Okay, let's go to the last problem now. Last problem is actually very difficult, like as you can see by the number of submissions also. So like relatively this is like the most difficult, and the difficulty ratio gap is significant between G and H. But actually, like once you get it, solution is super simple. Okay, so I will try to explain, but yeah, I mean this needs some like little bit prerequisite, but yeah, you can like read through it. So main idea is that whatever these -1 +1s are there, right? -1 +1. So I'm making a statement basically. Whenever it's 1, think of it as true. Or not even true. Whenever it's 1, think of it as same number, and the -1, think of it as a complement. So let's say if minus a2 is there, right? Then think of it as a a2's complement. So the eventual idea is that in the array also 1 -1, all those things are there, which would mean that 1 is true, -1 is false. Like it may be sounding weird, okay, what the hell I'm saying, like why I'm saying okay, -1 true, false, or whatever it is. But when the moment I tell the solution, it will become very obvious why I'm trying to set that context in the beginning. Okay, so solution is like super simple. So there is this problem 2SAT, which is you will have statements like this. You will have lots of statements like this, and we want to tell if there is a assignment of these A, B, C, which is like a Boolean assignment, whether that assignment is true or not. So like you can read about it. 2SAT can be solved by making a graph, and then we see basically okay, which components are strongly connected or not, and whether it is possible to have an assignment. But the main idea is that in that graph we add sort of edges like this. A, if complement of A is true, so this S edge is coming from first condition. If complement of A is true, which means A is false, then B have to be true. Similarly, we'll have B's complement is true, then A have to be true. Why? Because at least from this scenario, right? From our condition, at least one of them have to be true. If one is false, then other have to be true. If one is false, then other have to be true. So in this problem, we actually have this thing, right? We want to make sure whether the middle row is 1 or not, which means we are sorting it, right? So if middle row is 1, then the third row is also 1, which means that at least 2 ones are needed. Can you try to feel the similarity? Like for these edges cases, actually, we need the similarity. So idea is, if we have like in our 3 rows, if we have a scenario like this, A1, A2, A3, then if in the same, we can make a same kind of graph which would have these A1, A2, A1, A3. Why? Because in every column we need at least 2 ones. So if any of the number is 0, if any of the number is 0, then other both of those numbers have to be true. So if a1 is 0, a2 have to be true, a1 is 0, a3 have to be true. Similarly, we would have statements for like this. If a2 is 0, a1 have to be true. If a2 is 0, a3 have to be true. So like we just uh, build the same graph as we built in two sat problem for this problem, and then we just use the exact same like solution. What we do in that, basically we converted it into the same form of graph. If you don't know two sat, then you can read about it on CP algorithm website. It have like very good explanation for this complete algorithm. Okay guys, hopefully this was useful and you guys understood. The problems contest have also just ended. Let me try to upload this video as soon as possible. But yeah, I hope it was useful. Comment and subscribe to the channel. It really encouraged me to like make more videos like this. Okay, bye bye.